Very good morning, students. This is Jay Vishakan. Today we are going to, for this session, today we are going to solve a problem from friction, a simple contact with different concept, right? Let me just read out the question here. A force of 300 Newton is required just to move a block up, inclined at 20 degree to the horizontal. The plane is being inclined at an angle of 20 degree, right? The force being applied parallel to the plane. If the inclination of the plane is increased 25, the force required just to move the block up is 340. Determine the weight of the block and coefficient of the friction. See, as far as this question is concerned, they have not given the drawing or picture. So from the wording, you will have to construct the drawing. So for which you should understand the inputs on the question. You should first understand the question thoroughly. Then only you can draw the right appropriate diagram. So look at here. There are two conditions. When the block or the body is moved, the body is to be moved up, the force record force is 300 Newton and the plane is inclined 20 degree. Second, the same block, if we incline this particular plane from 20 to 25, the force required to move the block up is 340. So they are not given the weight of the block and the coefficient of friction. So let's list down the given data. First condition, force is equal to P equal to 300 Newton and theta is equal to, that is angle of repose, theta equal to 20 degree. This is case 1. For case 2, P equal to 340 Newton and angle of repose theta is equal to 25 degree. To find weight of the block and the coefficient of friction, which is nothing but mu. Solution. Since the diagram is not being given, so we'll have to draw the diagram first. The first condition, case 1. Case 1, so the plane is inclined at an angle of 20 degree and the force is applied is parallel to the plane. Great. So this is 20 degree. The plane has been inclined at an 20 degree and a block is being kept over it. Its weight is unknown, that is W, right? A force is being applied to move the block up, that means block up. That means you have to apply the force here, or this is push, and you can just mention here also, nothing wrong. So this I taken as P, which is 300 Newton, P equal to 300 Newton. So this is the drawing. So now I am going to draw the FBD for this. Going to draw the free body diagram for this picture. So I am considering this is horizontal, x-axis, and this is y-axis. Now this is the P, which is 300 Newton, correct? When this is 20 degree, when this acts like this, what about this angle? This could be 90 This is 20. So our internal angle of triangle is 180. Therefore 90 plus 20 is 110. The balance is 70. So it should be 70. So this can be written as W sine 70, and this can be mentioned as W cos 70. There is a reaction which will be always perpendicular to the object. So which is N1. The condition 1, so N1. When the block is moving in the upward direction, so the friction would be opposite to the movement or motion. So this can be considered as F1. Is it clear? So if you want, you can just draw another diagram also if you want to understand. So I just making one more drawing for your better understanding. So this is the axis. This is again FBD. This is the normal diagram. Then just drawing a FBD of this. This is N1, and this is the weight, which should be W sine 70, and this is the weight of horizontal component, W cos 70, N, and since the block is moving upwards, so the friction force should be in the opposite direction, right? So now I'm going to applying equilibrium condition. What is the condition? Summation h is equal to 0 and summation v equal to 0. Correct? Right. So let's first resolve the horizontal forces first. 0 equal to, this is positive direction, so 300. F is in negative direction, F1. And the weight is in negative direction, 70. So this can be written as F1 equal to, F1 comes here, this should be 300 minus W cos 70. Equation number 1. So going to resolve the vertical forces now. 0 equal to vertical force which is downwards, which carries negative symbol, W sine 70, N1 in the positive direction, N1 equal to W sine 70, right? As you know, mu equal to F by N, that is limiting friction to the normal reaction. So F value, that is 300 minus W cos 70, and N value from the equation number 2, which is W sine 70. So mu1 equal to, and this equation number 3. So now we are going to solve the case of second case. What the second case says, when the block is inclined at an angle of 25 degree and the force required to move the block up 340. So let's consider case 2. So the angle of repose is 25 degree, and the block weight is W, and the force applied here P equal to 340 Newton. So this is a simple sketch. Now I am going to draw the FBD for this drawing. So draw horizontal line, and this is the inclined plane 25 degree, and a block. This is x-axis and this is y-axis. As you know, the weight always act vertically downwards. Then what about this angle? If this is 90 degree, what about this angle? 90 minus 25, which is 65 degree. So the weight for this W sine, this is a vertical component, always sine. So sine 65, and for the horizontal W cos 65, the external force to move the block up is 340 Newton. The normal reaction which should be perpendicular to the surface of the body or block, right? So when the block started moving upwards, its frictional force would be opposite of the moment or the direction of motion, which is F2. So I'm just going to redraw this as this FPD, so in a simplified manner, so which won't confuse you when you consider the resolution of force. So this is horizontal force, this is vertical force, this is horizontal force, and an external force is act, and the normal reaction and the friction F2. This is 340 Newton, and the horizontal component of weight is W cos 65, and the vertical is W sin 65, right? One, two, three, 4, 5. 1, 2, 3, 4, 5. When you transfer any information, you just count number of forces, so that you make sure whatever the forces acting on the block, so same thing you have transferred here. So now applying equilibrium condition. What are the conditions? Summation h is equal to 0 and summation v equal to 0, right? So now resolve the horizontal component. Summation h is equal to 0, 0 equal to 340, which is in the positive x direction, and this weight is in negative direction, and the F2 is also in the negative direction. So F2 can be written as 340 minus W cos 65. Consider this equation number 4, because we already mentioned 3, so therefore this should be 4. Now going to resolve the vertical forces. 0 equal to vertical forces. How many forces are there? 1, 2. N2 minus W sin 65. So N2 becomes, when this comes here minus, then it would be plus W sin 65. Equation number 5. As you know, mu equal to F2 by N2, which can be written as 340 minus W cos 65 divided by W sin 65. equation number 6. So equate equation number. So these 1 and 2 are same. So mu, because it's a one and the same. So mu 1 equal to mu 2 equal to mu. So this can be written as mu, because of the same object, right? As the same object where the angle of inclination is increased and the force applied to move the block is also increased. So it's the same block and same plane. Therefore, this coefficient of friction is uniform. Right, now equate equation number 3 and 6. So 300 minus W cos 70 divided by W sin 70 equal to 340 minus cos 65 divided by W sin 65. We'll have to do the cross multiplication here. So W sin 65, that is 300, W 600 minus cos 70 into sin 65, 0.31 W square. Correct? So when you just do it here, 340 into W sin 65 minus sin 70 into cos 65, 3.397 W square. 300 into sin 65 should be 271.89 minus 0.31 W square equal to 340 into sin 65, 308.14 W minus 0.397 W square. So let me just bring this W square this side and W in the other side. That becomes 0.397 minus 0.31, which is 87 W square. $271.89 minus 308.14, 36.25 W equal to 0. This is in the form of ax square plus bx plus c equal to constant. What is exactly it is? Yeah, quadratic equation. So W equal to minus b. So this is a value, this is a value, and this is b value, and this is c value. So minus b plus or minus root of b square minus 4ac divided by 2a. When you just substitute all those values here, so since c is 0, this becomes 0. B value is minus minus plus, so 36.25 plus 36.25 square root and root, so this is also 36.25 equal to divided by 2 into a. 2 into a value is 0.087. So there is a calculation error over here. This is 319 instead of So you'll have to be very careful while using the calculator. So 47.61. So B value is 47.61 plus 47.61 divided by 2 into 0.087, right? So which works out to 547.24 Newton. W is equal to now substitute this value in any of the equation, either 3 or 6. Substitute W value in equation number 3. You will get mu equal to 300 minus W is 547.24 into cos 70 divided by 547.24 into sin 70. Mu equal to 0.22. So is it clear? So you'll have to be very careful while using the calculator. So it's a calculation for if you encounter any mistake that leads to the wrong answer. So you have to be very careful. Thank you.